Hi everyone, I'm Ece from No More Research. Today I will be presenting our demo paper on low latency dash, more than just a spec dash-IF test tools. In this presentation, I will first introduce Dash Industry Forum, shortly called as dash-IF, its activities and testing tools. I will then show a demo based on its recent study on low latency dash. As many of you might be aware, MPEG-Dash is one of the widely adopted streaming formats for streaming services over the internet. As Dash-IF is an organization founded to promote Dash and catalyze its adoption in the multimedia industry, Dash-IF has been one of the key enablers in this. Founded back in 2012, the forum currently has more than 80 members, including service providers, broadcasters, and CDN operators, that altogether represents a large footprint of the multimedia ecosystem. Since its foundation, the organization has published several interoperability guidelines and helping materials, including testing tools, to support interoperable data streaming. Also, Dash-IF serves as a point of contact for other industry partners and standardization bodies in introducing new Dash-based services. One of the latest interoperability studies is low latency Dash. This study, together with the testing tools, are the main highlight of this demo presentation. As I have mentioned, Dash-IF leads the development of many testing and reference tools. I will introduce each of the tools in more detail in the upcoming slides, but in short, Dash-IF provides three different categories of testing tools. The first one is the Conformance Validator, and it validates the Dash content and its signaling for a defined Dash service. The second category is the test assets, and they provide sample testing materials consisting of Dash content and its signaling for a variety of Dash services for public use. The last and final one is the Dash.js reference player, which provides a reference client implementation. So from here, it can be said that they all together form a wide testing ecosystem, varying from content creation to service providing to service consumption. All work in Dash-IF is supported by these tools, and they provide valuable feedback for interoperability discussions, development of each of the tools, as well as for content distribution deployments. Here in figure 1 on the right side of this slide, we can see a baseline architecture of content distribution system and in which part of the system each of these tools can be useful. Each of the tools are made publicly available for community use and contribution, and therefore they are encouraged to be used by implementers, client player developers, and service providers. Let us give more detailed information on each of the tools since they are being used in the demo that we will show later on. The first one that I will introduce is the Dash-IF Conformance tool. The Dash-IF Conformance tool, or the Conformance Validator, is used to validate Dash content according to Dash-related media specifications. And the specifications that the tool supports include a large set from MPEG, CTA, HBB-TV, and DVB. The tool also comes with an easy-to-use and interactive web interface, as you can see on the left side of this slide. And it provides reports in runtime on expected or unexpected behavior that can be observed in the provided media services that are aimed to be working actually in alignment with a subset of these standards. More specifically, for each aimed standard, the tool validates first the MPD itself and check if it is formed properly. Then it validates the segments within the MPD and checks if they are signaled properly and if they are generated properly. And finally, it validates the cross relations of the alternative media streams in the MPD and checks if they are signaled properly. Beyond this, the tool itself also provides another tool, what is called Dynamic Service Validator. This also comes with its own web interface, and it validates if the segments in a Dash live service are signaled such that they conform to the defined Dash timing model. All these are open source and available for use in the provided links on the bottom left part of the slide. The is the test assets category. Test assets provide sample MPDs and Dash packaged content. This makes test assets be of ultimate importance for client developers to ensure large-scale interoperability. For this, DashIF has developed two tools, namely Test Assets Database on the left-hand side and the Live Source Simulator shown on the right-hand side. Within DashIF, many test vectors have been created for the defined use cases, and the Test Assets Database was developed to host these in an organized way for public use. It hosts currently more than 300 test vectors covering a wide variety of use cases, and they are listed on the left-hand side over there. Live Source Simulator, on the other hand, is used to create and test reference Dash live services. For this, it uses a video-on-demand content and converts them to live service. Conversion to the live service is done based on an input configuration parameter list that is listed one after the other in the HTTP URLs, and in return the tool gives the properly defined MPD and the segments for the desired Dash live service. This tool also supports a wide variety of configuration options that covers many different service features as also listed on the right-hand side. And again, all these tools are open source and available for use in the provided links on the bottom part. The last tool is an MPEG Dash player called Dash.js Reference Player, providing a reference client implementation. It is written in JavaScript and it relies on media source extensions and encrypted media extensions, which are supported by many client platforms, which in turn makes Dash.js also a prominent option to be used as a foundation for a production-grade player. It provides a wide set of features, including but not limited to video on demand and live playback services, DRM, subtitle, closed caption support, low latency playback, as well as different adaptive bitrate switching algorithms. It also optionally provides useful information on the playback itself, such as latency, buffer level, losses, and many more. And once again, this tool is also open source and available for use in the provided links on the left-hand side. Now that we have gone over the tools, I will explain the demonstration that we have proposed in our paper. With this demo, we wanted to show how to use the available DashIF tools and provide an understanding of how they are related to each other, how they can be useful in multimedia-related developments and deployments, and promote their usage. To make the demo interesting, we have selected the current hot topic, low latency Dash. This is a new extension to the interoperability guidelines, and it defines how to provide the consistent latency in Dash-based linear TV services. The simple operation flow for a low latency Dash service can be seen in figure 2 on the right hand side of this slide. And here the Dash packager gets information on the general description of the service as well as the encoder configuration. This information is necessary to ensure the correct signaling and mapping in the MPD. The encoder on the left hand side produces the CMF chunks and fragments. As each chunk is generated by the encoder, the Dash packager maps them onto the corresponding segments and provides them to the network in the same manner. This makes the segments be available for clients before their completion. In this demo, we showcase a simple low latency live Dash service. In this regard, each tool has already been developed to support the defined low latency feature. This service is generated by the Live Source Simulator tool, then validated against low latency requirements by the Conformance Validator tool, and finally played back by the Dash.js Reference Player. Since there was not too much time, unfortunately in the demo video we could not include the conformance validation part. However, everyone is welcome to test it on their own or contact us. Now we can see the demo that one of our authors, Daniel, has recorded and explained.
In this example, we will showcase how to play CMOP low latency streams coming from the DashIF Live Simulator in Dash.js. Before we take a look at the playback in Dash.js itself, Let's take a look at the manifest first and identify new attributes regarding low latency streaming. The first two new attributes we can see are located in the segment template element. These are namely availability time complete and availability time offset. By setting availability time complete to false, the client can infer that segments are available at its announced location prior to their completion. So this pretty much tells us that CMOF low latency chunks are available. By setting availability time offset, the client can calculate how much earlier those segments are available compared to their computed availability start time. In this case, we have a segment duration of 2 seconds, and availability time offset is set to 1 second. So from this, we can infer that the CMOF chunks have a duration of 1 second. What we can also see at the top of the manifest is a new attribute or a new element called service description. Using the service description, we can set the maximum latency, the minimum latency, and the target latency on the client side. In this case, we tell the client to place 3 seconds behind the live edge, but he is also allowed to switch up to 6 seconds, but should not go below 2 seconds. Whenever we do not reach our target latency, we can use the playback rate to catch up to that target latency. In this case, we tell the client to stick to a certain playback rate, which is a maximum of 1.04 or a minimum of 1.96. So whenever we get too close to the minimum latency, we decrease the playback rate. Whenever we get too close to the maximum latency, we can increase the playback rate. What we can also see is a new attribute called producer reference time at the bottom of the manifest. The producer reference time is currently not used by Dash.js, but it will be used in the future. The producer reference time allows us to control the latency between the production of the media time and the playout. So it pretty much gives us the time of the production of the associated media. So let's take a look at a concrete example now. In this case, I opened up the standard Firefox browser using the latest Dash.js version, which at this point is 3.1.2. In our example, we will use the live stream coming from the Dash.if live simulator, which I explained previously. So first of all, I will start playback without low latency mode. So I click on load on the right side, and then we can see the target latency or the live latency on the right side of the player's panel. So in this case, we achieve a latency of approximately 10 to 11 seconds. At this point, we are not using CMOF low latency chunks. So we pretty much stick to standard live playback using complete segments or complete fragments and classic XHR request objects. So if I reload this page now, and then we enable low latency mode, then the player will use CMOF low latency chunks and the fetch API for playback. So in this case, I go on show options, I enable low latency mode, and then I start the playback again. What you can see right now is that the live latency decreased to 3 seconds, which is pretty much what we are aiming for because we defined a target latency of 3 seconds in our manifest file. Moreover, when we take a look at the network tab, we can see that the player actually uses the fetch API and that the segments are coming from the server using transfer encoding set to chunked. So in this case, we achieve a much lower latency and the buffer is still stable at around 2 seconds. So this pretty much completes our example. If you want to try out low latency playback in Dash.js, you can use the live simulator. You can even check your own live streams against the Dash.if validator, and you can use Dash.js as your reference client.
Thank you very much for your attention.